Hola clase. In this video we are going to go through the proof of the quotient rule that we've already seen, and it's a rule, a derivative rule, that allows me to derivate quotients of fractions, fractions that are dividing each other. Remember, we're going to start from the same point that we start every single proof, my derivation by first principles. The function that I want to derivate now, it's going to be a quotient or a fraction of them, f of x over g of x, and just so I don't use h, I'm going to call that k. So we're starting same as we've seen in previous proofs before, substituting this into the derivation by first principles and asking, okay, what would k prime of x be? Right, limit of h tending to 0 of function of x plus h. Now what I've got is f of x plus h over g of x plus h minus function of x. Well, that's function of x over g of x, and all of that divided by h. Now, that is what a differentiation by first principle tells me. Now, I'm going to think of these functions independently. If I could only have f of x, I could be able, no problem, to get f prime of x. It could be f of x plus h minus f of x, all of that divided by h. If this is true, which it is, then I could leave f of x plus h alone. How could I do that? I would have to cross multiply here, that h would pass multiplying, and then this minus term would pass adding. So I would end with h f prime of x plus, because it passes adding, f of x. Exactly same thing for g of x. If I would be looking only at g of x, I would look at g prime of x, and then if I do the entire process exactly the same, I could have g of x plus h g prime of x plus gx. Exactly the same. Now with these two things, I would be able to come here and substitute them into this expression here. So I could have, I'm going to make a bit of space. That's horrible. I'm going to erase. Now, better, I've got a bit of space, and I'm going to begin substituting here. So, limit of h tending to 0, that hasn't changed, of f of x plus h, that I just said it's equivalent to this. So I've got h f prime of x plus f of x divided by g of x plus h. Same deal. I've got an equivalent here. I'm going to put it there. h g prime of x plus g of x minus f of x over g of x. I haven't touched it, so I just carry it on. And all of that divided by h. Alright, now what I've got here is a subtraction of fractions. So how do I sort it? I would need to cross multiply here, and then how do I divide fraction by fraction? These two are multiplying. So I'm just going to tidy all these. Limit h tending to 0, and then I could begin to cross multiply to get to one numerator. So g of x multiply these both terms, and I'm always going to put whichever marks f first, just to tidy them up, okay? So h f prime of x g of x plus f of x g of x, and then minus, and I cross multiply here, minus h f of x g prime of x, and the second one minus f of x g of x, and all of that divided by this product here, h times h g prime of x plus g of x, all of that times g of x. What I did, it's just multiply these two and then pass them into one common denominator. Alright, now I can begin to look at like terms and see what I can simplify. So I've got here f of x, g of x, I've got it here, so these two are going to cancel. Then each one of these terms has an h that I can simplify here. So now I've got all the h terms eliminated from the numerator, and I keep on looking. This one is not going to cancel with anything, so when I apply the limit, if h tends to 0, this term h times g prime of x is going to cancel because it's going to be as 0. Okay, what am I left with? Let's go here. This one, f prime of x g of x minus f of x g prime of x, and all of that divided by whichever was left here, which I've got g of x multiplying g of x, that's g of x square. If I call f of x u and g of x v, that turns into what? U prime times v minus u v prime, all of that, v square. And that was what we were searching all along, which was the derivative of our function. Now we've got it all tidy, we prove it, so now we can name it. And because this function was the quotient of fractions, this is the quotient rule. Once again, you don't have to believe me, you can believe the whiteboard because the numbers don't lie. I've got my proof, and then every time I've got a quotient, I can use it. Thanks for watching.